Hello and welcome back. We've got another log problem here. Let's look at it. We've got prove that log base ax is equal to 1 on log base xa. So let's write that one down. Log base ax is equal to 1 over log base x a. So I want to leave the left-hand side exactly as it is. I'm just going to name it LHS, left-hand side. And I'm just going to manipulate this right-hand side over here without interacting with the equal sign. So this, I can use a log law, dropping the base, to make log base 10a over log base 10x. And then when I'm dividing by a fraction, that's the same as multiplying by its reciprocal. So that will equal log base 10x over log base 10a. And now, instead of dropping the base that I did up here, that x, I'm going to drop down into a fraction. Instead, I'm going to make this here into the new base of that log up there. So this will be log base a x. And now, the left-hand side is equal to the right-hand side. And that is a very weak proof that they are equal. And that's it. Just a bit of clarification for this section here. This is the same as saying 1 divided by, let's say, 1/5. And that would be equal to 1 times 5 on 1. So when you divide by a fraction, you can multiply by its reciprocal. And that's just what we've done there with slightly more complex numerators and denominators. Now that we've proven the first one, let's look at the second part. Hence solve log base x8 plus log base 8x equals 13 on 6, where x is greater than 1 and it's an integer. So x also is an element of integers there. Alrighty. Well, we want to get x by itself. So right now x is a bit of a problem for us because it's part of this base here. But what we can use is we can use our previous result and say, well, that first term is the same as 1 over log 8x plus log base 8x, which is equal to 13 on 6. So right now we've got x is inside of a log. That's okay so far. Let's see what we can do. Well, we don't want this x to be on the bottom of a fraction first of all. So let's multiply everything by log base 8x. We'll have 1 plus log base 8x squared equals 13 on 6 times log base 8x. Okay, so I can't really factorize the log base 8x, but what I do notice is I've got a power of 2 here. This power of 2 here, that's a really big clue to solving this problem. So if I let log base 8x equal a pronumeral, let's say it's a, you could use b, c, d, doesn't really matter. Make that a bit clearer. My a's always look like a's and never look like 9s. So if I rewrite my last line of work, 1 plus a squared, that'll equal 13 on 6a. Now this is looking like a quadratic that's quite easy to solve. So let's rearrange this so it's a bit nicer to look at. We can have a squared minus 13 on 6a plus 1 equals 0. I said 0. There we go. That's much better. And that's just the quadratic. You can put that into your calculator or use an online calculator to get a result and spit something out. I won't go through the quadratic process because we're here mainly to look at log laws and manipulating them to solve stuff. So we can just say a will equal 2/3, or we won't just say it. We know that it will equal this because I've used a calculator. Or a will equal 3/2. Now the problem is we don't want a. We want x. Where was x and a? So here's a, here's x. So we've got to remember, I'll just go up over here now. We've got log base 8x equals 2/3, or we've got log base 8x equals 3 on 2. So we're still trying to get the x by itself. So if we look at this left-hand side, we'll have x equals 8 to the power of 2/3, and that is just going to be 4. You can put that in the calculator and double check if you'd like. And over on the right-hand side, we'll have x equals 8 to the power of 3 on 2, and that will be, if you just put in your calculator, you get something like 22.627, etc. And that's not an integer. This is out. No thanks. Over here, though, this 4, it is bigger than 1, and it is an integer. So we're happy with that. Hooray. That's it for today. Thanks for joining me, and I'll see you next time.